Thank you for joining today's webinar. We're going to take a few minutes to let people file in and get settled, and we'll start it up about a minute or two after the hour. Again, thanks for joining. Again, if you're just joining us, thank you, and we will begin the webinar about a minute or two after the top of the hour. Good afternoon. Welcome to today's webinar, Accelerate Sheet Metal Stamping with Dynaform, a complete virtual die development solution, and hosted by Metal Forming Magazine. I'm Lou Kren, Senior Editor of Metal Forming, a publication of the Precision Metal Forming Association, and I'm pleased to be today's moderator. Before we get started, just a few notes about today's Zoom meeting session. This meeting is being recorded for archiving, and the recorded event will be posted to our website within the next few days. And we will let you know via email when the recorded webinar is available for viewing online and for sharing with others at your company. Also, all participants in this meeting are in listen-only mode. The speaker and other listeners will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout the program by submitting your questions and comments using the Q&A link located at the bottom of your Zoom screen. Questions will be addressed in the time allotted at the end of the webinar presentation. Okay, so now it's time to begin today's webinar, focusing on Dynaform, a solution for virtual die development in sheet metal stamping developed by Engineering Technology Associates. This session will walk through the full suite of Dynaform modules designed to optimize the stamping process from concept to production. Today's speaker is Ming Zhang, Tooling and CAE Specialist at ETA. He has more than a decade of experience in virtual die development and sheet metal forming simulation. A graduate of Michigan State University, Ming has been with ETA since 2013, where he has played a key role in supporting the development and advancement of Dynaform. With a strong foundation in general CAE, including crash modeling and structural analysis, Ming brings a holistic engineering perspective to stamping simulation. Without further ado, here's Ming Zhang.
Thank you very much, Lou. And good afternoon and welcome everyone for joining our webinar today. Our topic is accelerated sheet metal stamping with Dynaform. My name is Ming Zhang. I'm a tooling and CAE specialist at the ETA. I have more than 12 years experience doing the software training and technical support for Dynaform. We are excited to partner with Precision Metal Forming Association. PMA has hosted many amazing events for many years, so we are very glad ETA can be part of it. Here is what we will cover today. We will start with a brief introduction to ETA, followed by an overview of Dynaform. Then we will explore the stamping industry's workflow and challenges. Before diving into Dynaform's key module, there are blank edge engineering, formability simulation, die face design, cube bending and forming, and die system analysis. We will wrap up with some exciting news at the end. If you have any questions during my slide, please type them in the QA window and we will address them later. So we also will have some a few pool questions. So here comes the first question. So your feedback will be appreciated. About ETA. ETA was founded in 1983 and has been innovating for over 40 years, delivering consulting, staffing, and software solution with a strong focus on CAE technologies. This is the map for our global footprint, headquarters located at Troy, Michigan, with offices in Germany, India, China, Japan, and Mexico. Also, our channel partners and distributors are all over the world. Okay, here is a brief summary of each decade in ETA's history. From 83 to 93, as one of the pioneers in CAE world, ETA started as a preferred tier 1 for the big 3 in Detroit, Michigan. We also started coding tools. Dynaform is one of them. From 93 to 03, ETA formally launched the software like Dynaform, VPG, and FEMB, has completed 20 global full vehicle projects. From 03 to 2013, ETA kept serving the auto industry with many projects done and kept improving our software. From 13 to 23, ETA started using AI and machine learning for optimization. We also launched our software on the new platform, added the reverse engineering and the benchmarking capabilities to make us a full service engineering company. Our engineering division has delivered over 50 full vehicle programs, where we were responsible for design and development for crash safety, NVH, and durability. We have our staffing division as well as an in-house consulting team. We also have a benchmarking capability where we can perform a complete teardown and provide a scan data and do competitive benchmarking. So we can support our clients in any attributes of development as listed here: styling, packaging, interior, exterior, chassis, even the body structures. We also have a capability to do all type of CAE simulations, from basic static analysis to complicated crash, occupant safety, NVH, CFD, chassis, and so on. Lately, we also have added capabilities related to the battery and controls. Here is one of our reverse engineering facilities. We have a database for over 100 vehicles, with most of them being EVs and lots of them from China. This is a well-structured database where user can subscribe to get access to whole thing, or can get a la carte access specific to their interest. So one of the benchmarking exercise we carried out for a commercial delivery vehicle, where we did a complete teardown, then generate a 3D CAD model with a BOM, and then it was benchmarked for crash and NVH. Our overall clients portfolio, it includes many OEs and tier ones. These partnerships shows our reach, serving global OEM and tiers suppliers across automotive, aerospace, and other manufacturing sectors. Dynaform's trust is built on years of proven delivery accuracy and measurable ROI. Dynaform is a complete end-to-end stamping simulation platform. It could help you finish your work with a reduced cost, time saving, but still with a high quality and accuracy. Our market include automotive, aerospace, electronics, and consumer products. Wherever sheet metal forming is critical, Dynaform provides measurable saving in material waste, tooling loops, and time to market. So here's the Dynaform legacy. We started our code with Ford in 1983. During these years, ETA keep improving the function and codes based on the demand from the market and the request from our customers. 2019, Dynaform was reborn with by moving to a new software platform. In 2023, with the die face design added to Dynaform 7.0. In 2024, with the advanced die face design, sheet drop test, and hot forming added, it become a comprehensive end-to-end solution for sheet metal forming. Here shows the stamping workflow. Dynaform shows its value starting from the early styling and planning feasibility, and then product design, die process, to design and validation. Common challenges and issues Dynaform could resolve. There are like inaccurate result from the past simulation, long setup times, and the complex workflow, high dependency on senior specialist, like ROI concerns and the missing integrated approach, Dynaform's single environment workflow and the built-in optimization tools address these challenges head-on. So now we also will have another two questions for the pool. Please answer them. That will be very helpful. Thank you. Well, these are the main modules in Dynaform. There are blank sets, engineering, die face design. Actually, with the die face design module, the die designer do not need to use the CAD software anymore. It can complete the die design with a quick evaluation in a very, very short time. And also we have the formability simulation module, which is the star module, most famous module in Dynaform. Also, we have die system analysis, sheet drop test, tube bending and forming, plus the scrap shedding, die transfer simulation. Uh, it is powered by the SIGFORM solver, optimized for speed and accuracy. We will go through each of them in the following slides, also with some short videos. Here are some general features in Dynaform. It supports many generic CAD format, like a CATIA and NX. Also, a geometry manager allowed user to do the basic surface cleanup and editing without the CAD tool. Also, this option center will keep users preference. They will be saved in the default configure file. With the SIGFORM solver, simulation runs about 3 to 4 times faster than before. Okay, then we will jump to each module. We will start with the blank size engineering. So BSE provides accurate blank size estimation and nesting optimization to minimize scrap. It supports coil, plate, and multi-row nesting, handles tailor weld blank and patch blank, and offer parting holes nesting. Batch mode can process multiple assemblies and generate a cost report in PDF, Excel, or HTML. The key features, like key functions in BSE, they are outline and the formability report, nesting, full 3D trimline, and the assembly BSE. Unfolding identifies the optimal blank size for single or multiple parts. Trimline development is done directly on the first draw die. BSE can account for part symmetry and special blank configurations for maximum yield. Use the unfolding calculation. It also provides user early formability result. It might not be as accurate as the incremental solver, but it could reveal some major issues in just a second. It could be very helpful on improving the part design without waiting for the long running time. Okay. Once user get the part unfolded, then the profile will be ready for user to run the nesting to show the utilization for the material. It supports coil, plate, progressive strip with many methods like a 1-up, 2-up, 2-pair, mirror, even the multiple blank combination. Multi-row and parting hole features really boost the yield by using scrap cutout to produce smaller parts. The system automatically evaluates and displays the highest yield combination. The report can be generated with one click. It's also a big plus for saving time. Here are the examples for multiple blanks nesting. You can see we have 3 parts in the left picture, and we have 2 different parts in the right picture. Also, multiple rows is used in the example in the left picture, and in the whole in the right picture. Yeah, imports multiple 3D parts or assembly to evaluate the formability, blank outline, and nesting in a batch mode. This is what the BSE assembly do. Instead of doing them part by part, user just need to import the BOM for defining the materials for each part. With one click, all parts in assembly will be unfolded, be running nesting, and the report will be created automatically. This saves the time in costing activities and increase the output quality. And here's another short video for showing the software. Here's the assembly BSE. You can see the user import the whole assembly. And just with a few clicks, each part will be unfolded, and then the report for the assembly will be generated. And this is the unfolding operation and the nesting. So user just need to, pick up the material, import part, pick up material, and then the unfolding can be done in just a few seconds. Then the formability report also post-process can be done easily. So here's the report. It is showing the thickness, thinning, strains, also the FLD. Yeah, with the uh, unfolding result, you can also check the result in the post-process. So here is a multi-row nesting. So you can do it in many ways until you find the best solution. So this is showing the part in holes nesting. So instead of waiting this space, you can put smaller parts in it. Also, the BSE support Taylor weld blank like this. You have maybe 2 different gauges or 2 different material. Also, we have the nesting part. Once you've done the nesting, it will provide you a report automatically. Okay, that's about the BSE. So we will starting from here, talk about the die face design and FS. We will see how they can be helpful our users. So the stamping industry faces challenges like unreliable simulation results, long setup times, dependence on highly skilled user, and difficulty justifying ROI. Many existing tools lack complementary solutions, aren't user-friendly, or are not widely accepted by OEMs. Dynaform was built to overcome these barriers. Die face design, DFD accelerate parametric die face creation with a regenerative workflow. So you can adjust and simulate immediately, and with the SIGFORM solver, it shortened the waiting time for simulation tremendously. Okay. Now we are looking at the workflow for die face design here. Normally we will start with a part, also this is a product. We'll do some geometry cleanup, preparation, maybe define the tipping to do some quick fill and morph. After that, we'll move on to the line die layout. Under the line die layout, we can recognize all the features and then also define the process, assign these features to a certain stage. A very typical process here is showing like a draw, trim, and then flanging. So then we can just assign the flange to the last stage, something like that. And then for the then we can move on to the die face. Here, what we do is we can use the software to generate the flange tool, also create a binder and then later generate the addendum, let the addendum trim with the binder to complete the die surface design. So once you get the die surface design, software can automatically generate all the tools for running the simulation. Also, we do support, carry over these surfaces or geometries you generated to the FS module, which allowed user to run a more detailed simulation, like adding the guide pin, define a specific binder force, use a line bead, virtual bead, or geometry bead. If they cannot do it in the DFD, they can do it later in the formability simulation module. We will now go through some key features in the DFD to see what it support and how we make the die face creation easier. So in part, preparation, after user import the product design into the database, user can do many quick editing. First, we support many type of the parts. You can see a lot of the demo parts at the bottom. So we do support a single part, double attached for the same part, or for the mirror, or for the rotated parts. Also, the boundary smooth double fill and end fill can be easily done here. Then binder design, user can create a flat binder or curved binder or user-defined binder. Drag a 2D control line, watch the 3D binder update in real time. If you need a symmetry, we also can mirror the control lines automatically. Addendum design. This is very important in the die face design. Software can create the external and internal addendum. We can also create some like a flange, counter bar, bar profiles, define global or segment by segment, or even doing the patch between two segments. Export services to any CAD system with just one click. Okay. After the die face design is finished, the program automatically generates the tools and locate them, put them into the right position for running the simulation. So to define the blank shape, the material, and the thickness, and quickly evaluate the design the die face using the built-in fast solver SIGFORM. Here's another short video about the DFD. The product and define the part, and also we can select the material from our material library. Here is the line die layout. Software will recognize all the features automatically, and also user can do more editing and assign these features into the process at a certain stage. Here is the binder design. So we can quickly generate the binder, and also control line can be added here. But by just dragging the nose up and down, then you can change the geometry of the binder. Here is the addendum generation by using the profile lines. And this is the trim planning, also with the automatic angle detection and defining. Here is the flange tool creation. Okay, after we define the flange and process, software can automatically take the geometry and generate the flanging tool accordingly. Here's the die simulation. This is run by SIGFORM. In the previous DFD module, we also mentioned that the die phase can be bring to the FS module, which is this formability simulation module. It's the main, it's the most famous module in Dynaform. It means if the surface are not generated in die phase design in Dynaform, if they are created in the CAD tool like a CATIA, NNX, SolidWorks Pro E, user can also easily set up the simulation in FS module. FS support tandem, transfer, progressive, Taylor weld blank, hydroforming, hot forming, and even the stretch forming. So it includes a spring back compensation and blank trimline development tools for optimization. It also can predict the wrinkle and crack to reduce the tryout loops. Here shows a multi-stage simulation, very typical sequence. Like OP10, we do the draw die. OP20, we do the trim. OP30, 40, we do the flange plus, restrike sometimes. OP55, we do the spring back and compensation, all in a single project file. No data loose between stages. Automatic optimization ensure trimline tolerance and the spring back control. Spring back compensation is used to take weeks for artisan level tweaking. Spring back compensation auto iterates until your part is within tolerance. Uniform or variable, hands-free. In Dynaform FS module, it also supports solid elements and hydroforming. 6 solid elements capture an isotropy and thickness changes. Hydroforming module lets you define the pressure curve and simulate with or without a punch. See the tears, wrinkle, or spring back before steel is cut. Cut tryout cycle by 50% or more, even the OEM's KPI. It also supports hot forming. 3 stages are included in the hot forming module, like gravity loading, hot forming, and the hardening. About the stretch forming, this is mostly for aerospace skins. Choose a transversal bull nose wrap or longitudinal stretch. Machine parameters are preloaded. Simulation ready in minutes. Okay, here's another short video about the FS module. First, it's showing the easy user interface, the new GUI. Here's the spring back calculation and compensation. So for this compensation, basically you just need to define the part, the tool you want to run the compensation, and the software will run the iterations by itself. Blank outline and trimline optimization, also very straightforward. You just pick up your target line and your initial line, then the software will run multiple iterations until it reach the target. We just call it convergency. Then once you get convergency, the iteration will stop. You can see this is one example. This is the initial simulation, and after optimization, it match pretty well. So this is the simulation data manager, allows user copy stages and create new iterations without starting over again. So you can easily copy the existing stage to create a new iteration. So this is the draw bead. Dynaform support a virtual bead or geometry bead. Also, just with one click, you can convert between the virtual bead and the geometry bead very easily. Here's the ETA report. It automatically link your simulation result with the PowerPoint, so you can do a future editing, or even just with change the result location automatically update all the report slides. So here it shows the multi-stage post-process. You see the animation of how a fender got formed and then trimmed, then flanging. So also there are quite a lot of post-process items you can check, uh, like a sinning, strain, major strain, in-plane strain, FLD. Also, you can do the surface quality check for the Class A. All right, after the BSC, DFD, and FS, there are also other modules in Dynaform. Die structure integrity is one of them. DSI module maps the stamping loads onto the die structure and predict fatigue life before metal is poured. Okay, and if you have any issue with the scrap removal, you gotta scrap the stocked in the chute stop the line. SSR module simulate the shedding trajectory, so you can validate the chute design before the die ships. Here is the sheet drop test. Large roof panel can deform during robotic transfer. SDT qualifies drop heights and angle limits. It can protect your Class A surfaces. Okay, sheet metal transfer and handling. Optimize the suction cup placement and X-bar timing before the tryout press even arrives. It reduces blanks interference, improving the cycle time. For tube bending and forming applications, we do have the module tube bending and forming. It automates setup and simulation, generating tools and the pressure curves with a multi-stage capability. In tube bending and forming, Dynaform supports a multi-stage. Defining steps are like a preparation. You can quickly fill the holes, fill the notch to prepare your part, and then do the die face design to generate the tools, and also generate all the bending tools, even directly from only a center line. You can give a center line, define the diameter, and then quickly generate all the tools with also the bending table. And preforming can be done after the tube is bended. So this tool will push the tube and make it ready for the hydroforming. Of course, at the last, you have the hydroforming, so it will hydroform the part to the final geometry. Okay, so this module automates center light creation, bending station, tooling station, and hydroforming setup for tubes. It supports multi-stage operation and variable pressure curves. So here is a very quick video about the tube bending and forming. What you see here is a post-process of the bending process. All these tools are generated in the Dynaform without the help of CAD software. Okay. Also, preforming and hydroforming, they are also supported. Okay, now let's talk about the SIGFORM solver. It is fast, accurate, robust. It handles explicit forming, implicit gravity, spring back, thin, thick shell, and even the solid elements. This solver also supports advanced material laws such as Bartlett 89, Bartlett 2000, and Yoshida. Now let's share some exciting news from ETA in 2025. Actually, it's the last month in July. Dynaform placed the second and Newman sheet, confirming its simulation accuracy against the real tryout result. So what is coming next for future Dynaform? First, we have a SIGFORM solver development, and we also plan to support more advanced material laws. For die face design, We will add more geometry modification functions. Also plus the FS module, forming simulation module, and also workflow improvement. Here is the roadmap 2026 and beyond. So we will work on the optimization and make the design work more robustic. Plus adding the data and intelligence technology. Also the Dynaform on cloud is also on the list. Okay, let's do a quick summary up here. Why Dynaform? It is a unified simulation platform with accuracy and reliability, time and cost saving. Not hard to start with, very user-friendly, easy to learn, with a wide range of application and also better collaboration. How we how can we help? With Dynaform, if you want to test the software, we can issue the 1 month trial license, also help on the benchmark project, even help you on the special process or special request. We have the ability to develop the customized code. Also, we can help on your part, even as a project as well. So if you are a PMA member, I guess you might be attending the events here. So if you are interested to meet us in person, see us at the FabTech Chicago 2025 September and PMA West Michigan October and APSC 2025 October, Nashville, Tennessee. Okay, so if you have any questions, please type them in the QA box.
Okay.
So Louis will bring it up.
Okay, thank you so much, Ming. That was an excellent
Yeah, no problem.
overview of Dynaform. And we have there is another poll up on the screen there.
Yes,
Now,
yeah.
as you know, if we could, there are a couple basic things before we get into some of the details of this solution. For example, you talked about the user-friendly nature of Dynaform.
Yes.
What is the learning curve for a new user? Do they need to be a simulation expert to get meaningful results from Dynaform?
No. With the old software, you might need to spend 3-4 days, even a week to learn the software. But with the new Dynaform, our basic training is only 1.5 day. Most of the users can easily get hands on the software to understand how the software works to set up the simulation, without knowing too much about elements and nodes and FEA to be an expert in that area. But if with a very basic die knowledge, like a die
Mhm.
101, you can easily set up the simulation.
Okay. And how about the hardware? Do you need an expensive, high performance computing cluster to run Dynaform? Can you comment on that?
No. Dynaform can be run on the local workstation, even the laptop. I finished many of these projects with my laptop. It used like i7 or i9 consumer CPU, but still it runs simulation pretty fast. I would say even for a big panel for body side, the size of like a body side, I can complete that with my laptop probably in 1-2 hours runs.
Okay. And I do want to remind attendees to use that Q&A panel for questions. Here's one from the panel.
Mhm.
Inside the die face capability of the software, in the example for curved faces, a curved C sheet with a bed in its center, is that to improve stiffness?
With the counter bar, I think they are talk about the counter bar in the profile. That's to prevent with the different type of the profile in the addendum. We use these different profile to like avoid many things. Like sometimes you have too much material there. You want to avoid the wrinkle. Then you have a counter bar, maybe another hump or a high geometry shape. But sometimes you want to flatten it, you want to avoid the spring back, so you may add different geometry. So it's really depends.
Mhm. Okay. Uh, um, Now, obviously, spring back is a huge issue, with these newer materials and, the
Mhm.
unique forming attributes and things like that. How does Dynaform not only predict spring back, but also help compensate for it in a tool design?
So the software actually can run the iterations. It means after the first round of the baseline run is completed, the software will compare the after spring back geometry with the target geometry you want, and then software will do the compensation to the tools mesh and the rerun the simulation again, and then compare the result again. After multiple iterations, you will get very close uh, uh, compensated tool as the result. So also Dynaform can export this compensated tool into a geometry, not by converting the mesh to the surfaces. That's the old way. The new way we do it is we compare the before and after compensation mesh and then do the morphing to the original geometry. So it means the compensated surface are in very good quality compared to the old method.
Mhm. Okay. Again, a reminder to use the Q&A panel. Here's another question from that.
Mm.
The tool generated from the die face design module, can that be
Mhm.
extracted in CAD formats?
Yes, yes, it can export it as a stat file. You can read it in any major CAD software.
Oh, okay. So the Dynaform, does it have direct integration with major CAD platforms like NX, SolidWorks, Acacia, things like that?
Uh, yes, yes, we do not have we do not have the plugin, but we do support most of the generic format. If you save the part in the like part file in NX, CATIA part file or CATIA product file for assembly, we can directly read them, without converting these files into IGES or STAP. You can directly read them.
Mhm. Okay. And can you comment on the types of forming processes that Dynaform can handle? Is it just for simple draw operations, or can it simulate multi-stage progressive dies, for example?
Yeah, it can easily simulate a multi-stage. We have done I usually talk with the customer. We do have customer. They run the progressive die. They have 11, even 11, 12 stages. So Dynaform can handle that.
Oh, okay. Um, okay, here's another question from the panel, the
Mm.
Q&A panel. Is multi-stage design in DFD, is it feasible like OP10 uh, as forming OP20 redraw and so on?
Yes, yes, we do support that.
Okay.
So when you do the line die layout in one of my slide, it is where user need to define the process. Once you have multi-stage like a draw, then trim, then restrack and flange. Also, you can assign the features there and then generate the flanging tool for certain stages, for the flanging stages, and generate the draw die services for the draw die stages.
Mhm. Okay. We talked about some of the forming process that Dynaform can handle. How about rolling processes?
Uh, for the rolling process, this is what the Dynaform is not focusing on. Um,
Okay.
but we can consider that in the future.
Okay. And along those lines, a couple questions related, use for die spotting or predicting microstructure change and hot forming, some of those things. Can you
Mhm.
comment on any of that?
For the hot forming, I'm not the expert. If you have a future question, we can have our hot forming expert to answer them later, uh, after the webinar.
Okay, actually,
So you can
these,
contact us.
okay, these questions will be sent to Ming and the team after this webinar. So if something isn't answered on here, they can certainly get back to you to continue that conversation.
Yep.
And
I also bring my contact information here. If you're interested, you can scan the barcode, and also you have my uh, direct number and email there.
okay, great. And one more question here before we close.
Mhm.
If you could comment on the accuracy of the new solver that you mentioned for final validation.
It's a industry leading. I would say that um, it is faster. From our benchmark and test, it's 3 to 4 times faster than before, but no uh, co- confirmation on the accuracy. It's a very accurate.
Okay. And again, thank you, Ming, for that outstanding presentation and um, the Dynaform overview. And to our audience, thanks for attending today's program. We hope you found it to be valuable. Once again, an archive of the program will soon be available. When it's ready, you'll receive an email from us. Then you can review what you learned today and share it with others within your organization. This concludes the webinar. You may close your browser now and have a great afternoon. Thank you.
All right. Thank you. Thank you, Lou. Thank you, everybody.